Hello everyone. This video is dedicated to Koski on his new discovery of the quarter rite punch out from a disphenoid. As a new member of the space filler, missed by Inchwald and not capable to build from my modules. Well, all the above is wrong, and here we go why. Here we have a small cube and it's missing a quarter regular tetrahedron. This one. That's in here. All the blocks in here are single oriented, just to let David and Kirby know that we don't need left and right. This is again one of the examples. Now here we have a small cube, just like that. But here now we have a quarter regular tetrahedron inserted inside. It's undivided, it's a solid module. It's actually not a quarter regular tetrahedron because it doesn't exist in that scale. But it appears like that. That's a capability of my cube to demonstrate it even though we don't have this block. This is actually a solid kite in here. Now and here we have a 2 frequency cube, just like this one. This is 1/8 of that one, and it's missing a quarter regular tetrahedron. It's punched out or taken out of it, and that's exactly this one in here. Fits over there. So the formula is 1/8 of the quarter regular tetrahedron. That's this one. The problem here is that this 1/8 quarter regular tetrahedron, which is missing here, is being punched out from this cube and is half the volume of the rest of the modules. There are 3 double corners in here, all single oriented, left or right. And this quarter regular tetrahedron is half the size of these modules. So now this cube, if we would have a cube like that, it would equal 7 modules. Cube equals 7 is not too often mentioned because we are in a volume identity and the lowest common denominator. A punched out quarter regular tetrahedron is not congruent to the rest of the blocks. To make a volume identity, we would have to dissect each of these double corners again into half, like that. These are double corners. Where are the double corners? Here. Here are the double corners. Like that. And we would have to dissect this double corner which is inside in here like that, and it would look like that. So now this is what you see. This module in here is this module, but of course it's twice as bigger. So there is 3 double corners, and we would have to dissect these to half, just like I demonstrated. And now our small cube, this cube, if it would be a cube, complete cube, it would equal 12 modules. They would be all volume identical, but they would not be lowest common denominator. Our lowest common denominator is 6. So now we have a quarter regular tetrahedron in here. And this quarter regular tetrahedron which is missing in here is 1/8 of this one. So there would be this is 1/8 of this one, so there would be 4 of these making that, and there is 8 of these in here. That would be 32 quarter regular tetrahedrons in this large regular tetrahedron. Synergetic has 24. Now we go even worse, we have 32 blocks in here. So R cube with 3 times 32 is 96, just way too far from the lowest common denominator. Now here we have other possibilities just to show that we are in an endless way to do this. Here we have an octant, 2 octants fused, and We could punch out also a tetrahedron from it just like David done. This would be a base of one, this would be a base of the other, base of the third one, a base of the fourth one. Now we could derive 4 tetrahedrons from it. They would be same volume, identical like this quadriregular tetrahedron, but it would not match nothing in our set. And of course, cube equals 12 is not our lowest common denominator, so we could not do it. Here we have a quadroblate octahedron. That's this one. It has the same volume as disphenoid, and both these are listed in a chart. And we could also punch off the tetrahedron from this. 4 tetrahedron, this would be one base, this would be other, third, and a fourth. And we could make them in a volume identity, and each would have a volume of this single one, but it would not match any of them. Now let's go back to the disphenoid. So again, if we would dissect quadral rites, and these would be our base of our new tetrahedron, so there would be 4 of them derived, each would be volume of that one, but would not match any of these tetrahedron. It would not match the solid kite, it would not match the octant, it would not match a double corner, it would not match the T modules, even though these are all same volume identity. This is a module, it would not match the A module. This is a B module, it would not match the B module either, so it would be useless. So it would be useless, and it would not be challenging to any of my 1/6 tetrahedron, which are these ones. The quadrite or any of the other modules are just one of endless possible tetrahedrons, one of infinite. Characteristic tetrahedrons means that the whole chart, all structures on the chart are built by a tetrahedron characteristic to the whole chart and are all at the lowest common denominator. Here is the chart once again, and this is the characteristic tetrahedron, and this tetrahedron is characteristic to all these structures on this chart. Could be built strictly by this one. And it would be also at the lowest common denominator. Thank you all for your time.